In the heart of Renaissance Italy in the year 1564, as the bells of Pisa echoed softly across the river Arno, a child was born who would one day reshape the way humanity saw the heavens and the earth beneath them. His name was Galileo Galilei. Few could have imagined that this infant, born to a modest but intelligent family, would grow into a man whose questions would shake the very foundations of science and religion alike. The world of the 16th century was a place where art and faith ruled supreme, but reason and evidence were still confined within the boundaries of tradition. Yet, within Galileo, a spark of curiosity had already begun to burn, a spark that would one day ignite a revolution in human thought. The Italy of Galileo's birth was alive with change. The Renaissance had filled the air with ideas of beauty, discovery, and innovation. Artists like Leonardo da Vinci and Michelangelo had redefined the human form, explorers had expanded the map of the world, philosophers were rediscovering the ancient wisdom of Greece and Rome. Yet in the midst of this flourishing culture, the heavens remained a mystery governed by ancient belief. The earth was thought to be the center of all things, motionless, while the sun and stars revolved around it in perfect celestial harmony. This idea, born from Aristotle and Ptolemy, had survived for nearly 2,000 years. It was a universe of divine design, perfect and unchanging, and in this universe, there seemed little room for questions, but questions were precisely what Galileo was born to ask. His father, Vincenzo Galilei, was a musician, a man of thought and precision, skilled in the mathematics of harmony and sound. From him, young Galileo learned that the world was not only beautiful but measurable, that behind every note and every melody lay numbers and patterns waiting to be understood. His mother, Julia, was a devout and strong-willed woman, rooted in faith but supportive of her son's keen mind. From his earliest days, Galileo's world was one of both structure and wonder. He would listen to his father's lute and hear not just music but mystery. The vibration of strings, the play of frequencies, the hidden order of sound. Even before he could write, Galileo's mind was already trying to decode the rhythm of the universe. As a boy, Galileo's curiosity seemed endless. He would spend hours observing the movement of water in fountains and streams, watching how drops fell and rippled, wondering why some objects floated while others sank. He would gaze at the stars, fascinated by their fixed yet twinkling light. In the streets of Pisa, he would stop to watch craftsmen at work, carpenters, builders, blacksmiths, and study how they measured, weighed, and balanced their materials. Every act, every sound, every motion was a lesson to him, an invitation to understand how the world functioned. He was, in every sense, a child of observation, a born scientist long before the word truly existed. When Galileo grew older, his father hoped he might follow a stable and respected profession. In those days, the church dominated learning, and medicine was among the few sciences permitted within its walls. So, in 1581, at the age of 17, Galileo was sent to the University of Pisa to study medicine. The university was one of the oldest in Europe, its halls filled with the echoes of classical learning. But Galileo's heart was never in the dissection of bodies or the prescriptions of physicians. Instead, his mind wandered toward mathematics and the mysteries of motion. In lectures, as his professors spoke of humors and remedies, Galileo would drift into calculations, sketching diagrams in the margins of his notes. He wanted not to heal the human body, but to understand the laws that governed all bodies, those of the earth and those of the heavens. The young student found himself drawn to the works of Euclid and Archimedes. Their clarity, precision, and logical beauty spoke to him in a way that no medical text ever could. One day, while sitting in a cathedral in Pisa, Galileo watched a lamp swing gently back and forth from the ceiling. The movement seemed simple, but something about it caught his attention. He noticed that, no matter how wide or narrow the swing, the time it took for the lamp to complete each oscillation seemed almost the same. Fascinated, he began experimenting with pendulums, using his pulse as a timer, to test this observation. From that simple curiosity, he uncovered one of the first great insights of his life, the principle of isochronism, that the period of a pendulum's swing is constant regardless of its amplitude. It was not a discovery made in a grand laboratory or under royal patronage, but in the quiet, watchful mind of a curious young man. It was the beginning of Galileo's lifelong method: observe, question, and test. He had glimpsed the hidden order of nature, and it thrilled him. The same pattern that governed the swing of a lamp might also govern the motion of the stars. For Galileo, the world was not chaos, it was a grand, mathematical symphony waiting to be understood. But Galileo's curiosity came at a cost. His professors, bound by ancient authority, frowned upon his questions. At the University of Pisa, Aristotle was not merely a philosopher, he was a near, sacred voice of truth. His teachings on physics and motion were treated as unchallengeable. Yet Galileo began to doubt them. He questioned Aristotle's claim that heavier objects fall faster than lighter ones. He watched falling leaves, rolling stones, and splashing drops of rain, and what he saw did not match what he was taught. This conflict between what he observed and what he was told would become the defining struggle of his life. Galileo eventually left his medical studies unfinished, much to his father's disappointment. But his passion for understanding could not be contained. He began to lecture and write about mathematics and the natural sciences, sharing his ideas with others who were willing to listen. It was a difficult path. He had no wealth, no patronage, and no title. But he had what mattered most, an insatiable hunger to know. And in a world where obedience often meant safety, Galileo's curiosity was a quiet act of rebellion. In those early years, he faced not only skepticism but also poverty. He tutored students, sold small inventions, and struggled to make ends meet. Yet every hardship only strengthened his determination. He studied the works of ancient thinkers not to memorize them but to test them. He rebuilt the machines they described, replayed their experiments, and looked for what they had missed. He once said that he wanted to read the book of nature, written not in words but in numbers, geometry, and motion. This belief, that truth must be observed, measured, and proven, was revolutionary. The more Galileo observed the world, the more he saw patterns where others saw randomness. He watched the movement of a pendulum, the rolling of balls, the fall of objects, and began to form a language of laws that could be expressed through mathematics. To Galileo, mathematics was not just a tool, it was the very language of creation. He began to suspect that everything in nature followed principles that could be discovered by reasoning and tested by experiment. It was a simple idea, yet in his time it bordered on heresy. For centuries, scholars had relied on the words of Aristotle, not the evidence of their own eyes. Galileo dared to trust his senses, his instruments, and his logic. He was not content with believing, he needed to know. This restless need to verify through experience became his greatest gift and his greatest danger. In the candle-lit workshops of Pisa and Florence, he began to design simple devices, balances, pulleys, and inclined planes, tools that would later serve as the foundation of experimental science. He often tested his ideas in the most ordinary settings. Children's games, musical instruments, or even the movement of water in a basin, all became experiments in his hands. Where others saw play, Galileo saw patterns. Where others accepted mystery, he sought reason. In every flicker of a flame or echo of a sound, he sensed an underlying truth that could be measured and understood. His world was alive with questions. How do things move? What makes them stop? What holds the stars in the sky? By his early 20s, Galileo had already begun to earn a reputation as a thinker of unusual insight. He was appointed as a lecturer in mathematics at the University of Pisa, and later at Padua, where his lectures began to draw large audiences. But even as he taught, he continued to learn. His curiosity was not satisfied by answers. Each discovery only led to more questions. The boy who once watched a swinging lamp in a cathedral was now a man probing the mechanics of the universe. Through all of this, one thing remained constant: Galileo's faith in observation over authority. He believed that truth was not decreed by books or institutions, but revealed through nature itself. It was this belief that made him both a scientist and a rebel. For to question the accepted order of things was to challenge not just scholars but the Church itself, which claimed dominion over truth. Yet Galileo's rebellion was not born of arrogance, but of wonder. He was not trying to destroy belief, but to expand it, to show that the universe, in all its vastness, followed divine laws that could be discovered by the human mind. As his understanding deepened, so did his sense of destiny. He began to see his work not as mere study but as a mission, to uncover the laws that governed motion and the cosmos, to free knowledge from dogma, and to teach others to look beyond appearances. Galileo's early curiosity was not just intellectual, it was spiritual. It was a belief that to understand creation was in itself an act of reverence, and so, from the quiet streets of Pisa to the lecture halls of Padua, the journey of Galileo Galilei had begun. A journey that started with the curious gaze of a child would lead to discoveries that would change humanity's place in the universe. The world had given him life during an age of rebirth, and he, in turn, would give the world a new vision of itself. His curiosity was not merely a trait, it was a force, one that would carry him through conflict, condemnation, and triumph. This was the beginning of a story that would forever alter the way humans see the world above and the ground beneath their feet. For in Galileo's eyes, every motion, every sound, every shining star was a clue, a whisper of the grand design. And though he did not yet know it, his questions would one day unlock the universe itself. As the Renaissance light continued to glow across Italy, Galileo's curiosity deepened into something far greater than fascination. It became a relentless calling. He could no longer pass a single day without asking why, without testing what others accepted as final truth. The narrow rooms of Pisa and Padua were filled with the sound of scribbling quills, the soft tapping of glass and metal, the clatter of weights and levers, as he built crude instruments to explore nature's secrets. Each small discovery filled him with wonder, but it also stirred within him a sense of disquiet, for every answer he found seemed to contradict what the scholars of the age still taught. He began to question not just the mechanics of motion, but the very way knowledge was built. For centuries, the study of the natural world had been guided by authority rather than observation. Philosophers quoted Aristotle, priests quoted scripture, and few dared to doubt. But Galileo could not silence the evidence of his senses. He had seen pendulums swing in steady rhythm, objects fall at equal rates, and mathematical harmony hiding behind every physical motion. If such laws could be measured on Earth, might they not also govern the heavens? His reputation grew slowly but steadily. Students gathered around him, drawn by his lively teaching and daring ideas. Unlike other lecturers who repeated ancient texts, Galileo made his students experiment. He told them to drop stones, roll balls, and measure time. He wanted them to see the truth for themselves. He often laughed at the idea that wisdom could be found by memorizing the words of the dead. To him, the universe was alive, open, and waiting to be read through the language of reason. It was during these years that Galileo's personality began to take shape as we remember it. Bold, confident, and sometimes defiant, he was deeply devoted to his craft, but he also carried the pride of one who knew he stood at the edge of something vast. At night, he would walk along the Arno River, watching the reflection of stars on its surface, dreaming of a day when the heavens would no longer be bound by myth, but understood through mathematics. He once said that to study the stars was to learn the handwriting of God. Yet that divine handwriting, he believed, was written not in holy texts, but in geometry and numbers. The young scientist's fascination with mathematics also extended into the realm of art and architecture. He admired the way painters captured light, how builders measured arches, how musicians calculated intervals. To him, every discipline, music, art, mechanics, was connected by invisible threads of proportion and balance. The same principles that govern the harmony of a lute string might also govern the harmony of the cosmos. The son of a musician, Galileo carried the rhythm of numbers in his soul. When he looked at the night sky, he did not just see beauty. He saw a pattern, a structure, a design waiting to be revealed. But such thinking was not welcomed everywhere. In a world still guided by strict dogma, curiosity could be dangerous. Knowledge, after all, was power, and power in the 16th century belonged to the church and to tradition. Yet Galileo's rebellion was not an act of defiance against faith, it was a quest for truth. He believed that the universe was God's creation, and that understanding it was an act of worship, but he also believed that the Creator had given humanity reason as a tool to interpret his work. Where others feared contradiction, Galileo saw harmony between science and divinity. Still, to his peers, his ideas were unsettling. When he demonstrated his theories on motion, showing that Aristotle's teachings were flawed, many scholars grew uncomfortable. How could the great philosopher, revered for centuries, be wrong? Galileo's experiments were clear, but the habit of believing authority was stronger than evidence. Some professors refused to watch his demonstrations. Others dismissed him as a troublemaker. Yet Galileo's confidence only grew. He began to realize that truth did not need permission to exist, it simply was. By his early 30s, Galileo's relentless curiosity began to draw attention beyond the university walls. His inventive mind produced new tools for measurement, like thermometers and geometric compasses, which not only advanced his studies but helped soldiers and engineers in practical ways. He sold these instruments to earn a living, his hands shaping brass and glass with the precision of an artist. Each device carried a piece of his philosophy, that knowledge must serve both understanding and humanity. Even amid financial hardship, Galileo's home became a small sanctuary of thought. Friends, students, and thinkers visited him, and late into the night they discussed everything from music to mathematics to the mysteries of the stars. Candles flickered over charts, equations, and sketches. The smell of ink and wax filled the room as Galileo spoke passionately about his vision of the universe, one governed by laws, not miracles. His voice carried a conviction that inspired some and frightened others. He was not yet the famous astronomer who would later clash with the church, but within him the seeds of that conflict were already taking root. His belief that truth came from observation rather than authority challenged the entire intellectual order. Yet Galileo never saw himself as a destroyer of old ways. He saw himself as a builder, someone erecting a bridge between the mysteries of creation and the clarity of reason. It is said that when Galileo watched storms over the Tuscan hills, he would note the movement of lightning across the sky, timing the interval between flash and thunder. He studied the arcs of cannonballs fired in military demonstrations, observing how their flight curved and fell. He was fascinated by the flight of birds, the tumbling of leaves, the spinning of wheels. Every motion seemed to whisper a secret law. To him, the universe was a great book, and he was learning to read its grammar. His family, though proud, worried about his obsession. His father, nearing old age, sometimes urged him to secure a more stable income, to focus on safe topics, perhaps to return to medicine. But Galileo could not return to a life of silence. He once told a friend that he would rather discover one truth about the universe than inherit 1,000 gold coins. For him, curiosity was not a choice, it was a destiny. In those years, Italy's intellectual climate was changing. The printing press had spread ideas faster than ever before. Scholars from Germany, Poland, and England began to question ancient doctrines. Rumors of new theories about the universe, especially the sun-centered model proposed by Nicolaus Copernicus, were circulating through Europe's universities. Galileo, still a young teacher, read these theories with fascination. Though he did not yet publicly endorse them, they stirred something deep within him. Could it be that Earth itself was moving? Could the heavens be governed by the same laws as the motion of a pendulum? The thought was both thrilling and terrifying. Galileo began to imagine a cosmos bound not by divine perfection, but by natural law, an infinite machine running with precision. each part moving according to mathematical principles. This vision was revolutionary, and it began to define his philosophy. He started to see connections between the motion of earthly bodies and celestial ones. The same equations that described a falling stone might also describe the path of a planet. Such an idea, simple yet profound, would later shatter the old universe entirely. But for now, Galileo remained the curious observer, the patient experimenter. His early notes are filled with sketches of levers, pulleys, and rolling spheres. He built crude timekeepers to measure motion, using water clocks and pendulums. He recorded data meticulously, counting, comparing, repeating. He understood that discovery was not a moment of inspiration but a process of persistence. Nature, he believed, revealed her secrets only to those who asked with precision and humility. Even in moments of rest, Galileo's mind refused to sleep. He wrote letters filled with ideas, sometimes apologizing for their intensity. He corresponded with other thinkers, debating theories of motion and perspective. He read ancient manuscripts and questioned their logic line by line. To some, he seemed restless, even obsessive. But to Galileo, restlessness was the heartbeat of progress. He once remarked that the universe was like a vast labyrinth, and he intended to find the path that led to understanding. The city around him was alive with contrast. Cathedrals towered over bustling markets. The chants of monks mingled with the cries of merchants. Faith and reason coexisted uneasily, like two stars orbiting the same gravity. Galileo moved through this world with quiet confidence, aware of the invisible boundaries he was crossing. He respected faith, but he refused to let it limit his inquiry. To him, truth was not something to be protected from questioning, it was something that thrived on it. Years later, his students would recall the intensity in his eyes when he spoke. He would describe motion not as a simple act but as a story, a stone released from a tower, a body descending through air, a planet circling a distant sun. Every movement had meaning, every pattern a message. His lectures were performances, filled with energy and conviction. He would draw lines across the board, trace trajectories, and challenge his listeners to think beyond what they had been taught. In his presence, science felt alive, daring, almost sacred. And through all of this, the child from Pisa, the boy who had once watched a lamp swing in a cathedral, remained unchanged at heart. He still saw wonder in the smallest things, in the way shadows lengthened at dusk, in the rhythm of the waves against the shore, in the flight of a bird rising against the wind. That same curiosity that had awakened in his youth continued to guide him. He was still asking the same question that had begun his journey. How does the universe truly work? By the time Galileo reached his middle years, he had already laid the foundation for a lifetime of discovery. The skills he had honed, observation, measurement, reasoning, would soon serve him in ways the world could not yet imagine. The universe was waiting for him to look upward, to turn his telescope toward the stars. But even before that moment came, his understanding of motion and his method of inquiry had already changed the course of science. In the tapestry of history, Galileo's early years may seem like the quiet prelude before the storm, but in truth, they were the storm's first winds. It was in these formative decades that he forged his greatest weapon, the courage to ask questions no one else dared to ask. His curiosity was the lens through which humanity would soon see farther than ever before. In the end, Galileo's early life stands as a testament to the power of wonder. It reminds us that revolutions begin not with declarations, but with questions. With the gaze of a child who looks at a swinging lamp and dares to wonder why it moves the way it does. From that simple curiosity, a new world was born, a world where knowledge could no longer be confined to books or decrees, but discovered in the rhythm of motion and the silence of the stars. The story of Galileo's birth and curiosity is not merely the story of a man, it is the story of a new way of seeing. It is the dawn before the day of reason, the whisper before the roar of enlightenment. And though centuries have passed since that lamp first swung in the Cathedral of Pisa, its rhythm still echoes through time, reminding us that the smallest observation can open the greatest truths. For in the heart of one curious mind, the universe found its voice, and that voice, once whispered in the corridors of Pisa, would one day proclaim to all of humanity that the earth moves, and that knowledge itself must always move forward. In the golden light of an Italian afternoon, centuries ago, a man stood upon the ancient stones of Pisa's leaning tower, staring down at the cobbled square below. In his hands he held two spheres, one heavy, one light, objects that, to the world of his time, represented not only simple matter but centuries of belief. Those who watched from below could not have known it, but what they were about to witness would change the course of human understanding forever. For Galileo Galilei, this moment was not about spectacle, it was about truth, and truth, he believed, must always be tested, never simply accepted. By the time Galileo began his experiments on motion, he had already spent years questioning the teachings of Aristotle, whose words had dominated science for nearly 2,000 years. Aristotle had said that heavier objects fall faster than lighter ones, that the rate of fall was determined by an object's weight. It was a law that no one dared to question, a principle that scholars repeated as fact without ever testing it. But Galileo, born with the stubborn curiosity of a true seeker, could not accept such claims without proof. He trusted the world he could observe, not the one written in books. To him, nature was not a script to be recited, but a mystery to be revealed through experiment. And so, in the late 16th century, Galileo began the painstaking work that would redefine motion itself. The instruments he used were simple, wooden ramps, metal balls, pendulums, and water clocks, but his mind transformed them into gateways of discovery. He understood that in order to challenge the greatest minds of history, he needed not only courage but precision. Every experiment had to speak with the clarity of mathematics. Every result had to echo with logic that could not be silenced. The famous experiment from the Leaning Tower may have begun as a tale, but its spirit was real. Whether or not he truly dropped the balls from that tower, what mattered most was the idea, the radical belief that all bodies fall at the same rate when unimpeded by air. To test it, Galileo conducted repeated experiments, timing the descent of objects rolling down inclined planes to slow their motion enough for careful measurement. In an age before clocks could measure seconds, he devised his own timing devices using the steady rhythm of water flowing through narrow openings. Each drop became a moment, each splash a heartbeat of nature's law. As he rolled spheres of different weights down polished wooden ramps, Galileo recorded how far each one traveled in a given time. To his amazement, and soon his delight, he found that all objects, regardless of their mass, accelerated at the same rate. The heavier ball did not outpace the lighter one. Nature did not discriminate between stone and lead. Motion, it seemed, followed a universal rule. In this revelation, Galileo saw not just a correction of Aristotle's error, but the unveiling of a deeper truth. The universe was governed not by opinion, but by law, and that law could be discovered through observation and mathematics. For the first time in history, the behavior of moving objects could be described not by words, but by numbers. Galileo began to express motion in terms of measurable quantities: distance, time, and acceleration. He found that the distance an object traveled as it accelerated was proportional to the square of the time it had been moving. It was an astonishing realization. Behind every fall, every roll, every swing, there existed a perfect mathematical harmony. The world, chaotic as it seemed, was ruled by order invisible to the naked eye. As he refined his experiments, Galileo's small workshop became a theater of discovery. The sound of rolling spheres echoed through the stone halls of Padua, each strike against the end of the ramp marking the precision of his calculations. He would lean close to listen, counting quietly, his mind tracing patterns that would later be recognized as the birth of modern kinematics. To him, each collision was a conversation with nature, and he listened intently to what the universe had to say. But these were not merely experiments. They were acts of rebellion. Every ball that rolled, Every angle he measured was a challenge to centuries of belief. To claim that the great Aristotle was wrong was not a simple academic dispute. It was heresy against the intellectual order of Europe. Yet Galileo was undeterred. Truth, he believed, did not depend on authority. He once said, in questions of science, "The authority of 1,000 is not worth the humble reasoning of a single individual." His discoveries on motion were not confined to falling bodies alone. Galileo also explored the principles of inertia, observing how an object in motion tends to remain in motion unless acted upon by another force. It was an idea so far ahead of its time that even his contemporaries struggled to grasp it. He understood that if friction could be eliminated, a moving body would continue forever at constant speed, a concept that would later become one of Newton's fundamental laws. Galileo had glimpsed the hidden structure of reality long before the world was ready to see it. To communicate his findings, he turned not only to mathematics but to art. He sketched diagrams, plotted trajectories, and used elegant geometric proofs to reveal the laws of nature. His drawings, filled with arcs, lines, and carefully measured points, were not just scientific, they were poetic. They captured motion in stillness, the way a composer captures music in notes. Each curve on his parchment represented the heartbeat of the universe. Yet even as his experiments confirmed his ideas, Galileo faced resistance. Many scholars refused to believe that such simple experiments could overturn the teachings of Aristotle. Some even mocked his methods, saying that the rolling of balls and the dripping of water were toys, not science. But Galileo knew what they did not, that truth hides in the ordinary. He once told his students that nature's secrets are revealed not in miracles, but in the quiet consistency of her behavior. He had learned that the universe spoke a language, and that language was mathematics. His courage inspired others. Students at Padua began to conduct their own experiments, building upon his methods. The air around him buzzed with intellectual excitement. For the first time, young scholars were learning not through authority, but through evidence. Galileo's classroom became a birthplace of modern scientific thought, a laboratory of the mind where questions were not silenced but celebrated. In those years, Galileo also found himself fascinated by the relationship between motion and sound. His musical upbringing gave him a unique sense of rhythm and proportion. He noticed that the pitch of a sound depended on the frequency of vibration, and that vibration, in turn, could be expressed in numbers. It was the same harmony he found in motion, the same underlying order connecting music, mechanics, and mathematics. The son of a musician had discovered that the laws of motion were like notes in a grand cosmic symphony. The beauty of his work lay in its simplicity. Galileo had no grand laboratory, no royal funding, no advanced instruments. His genius was in his ability to turn the simplest of tools into instruments of discovery. A wooden ramp became a model of the universe. A dripping jar of water became a timepiece of cosmic precision. His method, observe, measure, test, repeat, became the foundation of what we now call the scientific method. He proved that even the mightiest truths could be uncovered with humble means if guided by sharp reason and unwavering curiosity. But Galileo was not satisfied with explaining how things moved. He wanted to know why they moved. He sought the hidden causes behind acceleration, the invisible hand that pulled objects toward the earth. He began to suspect that all motion was interconnected, that the fall of a stone, the flight of a cannonball, and the orbit of the moon were governed by the same universal force. Though he did not yet have the tools to define it, he had glimpsed the very essence of gravity. At night, he would sit by candlelight, surrounded by his notes, lost in thought. The city outside would sleep, but Galileo's mind would race with numbers and possibilities. He was building, piece by piece, a new vision of the world, a vision in which motion was not mystical but measurable, not divine but natural, not chaotic but governed by precise and elegant laws. His discoveries began to spread beyond Italy. Letters arrived from scholars across Europe, some eager to learn, others eager to debate. Galileo answered them all with wit and patience. his words carrying both logic and fire. He was a man of science, but also of conviction. He believed that reason was humanity's greatest gift, and that to use it was to honor the Creator who had given it. And yet, as his fame grew, so did the tension around him. The guardians of orthodoxy felt uneasy. If Galileo could disprove Aristotle about falling bodies, what else might he challenge next? The Earth's place in the universe, the structure of the heavens themselves. They sensed, perhaps before he did, that his path would soon lead him to even greater confrontations. Confrontations not just with scholars, but with the Church itself. But in this moment, before the telescopes, before the trials, before the accusations, Galileo was simply a man alone with his experiments, listening to the whispers of truth hidden in the rolling of a ball and the ticking of water drops. He had taken motion, one of the most common experiences of human life, and revealed it to be a gateway to the universe. What began as curiosity had become revelation. The stones of Pisa, the ramps of Padua, the small brass spheres that rolled endlessly in his workshop, these were the silent witnesses to the birth of modern science. Galileo's experiments on motion did not merely describe how objects fall, they taught humanity how to think, how to question, and how to see. The fall of a ball had become the rise of reason. As the 17th century dawned, Galileo's work on motion had already begun to echo through the lecture halls and academies of Europe. Yet in his small study in Padua, he knew that what he had uncovered was only the beginning. His inclined planes had revealed patterns, constant acceleration, equal distances, measurable times. But he sensed that these patterns were fragments of something greater, a universal order that stretched beyond the walls of his workshop. He was now chasing a law that could explain not just the fall of a stone, but the rhythm of the cosmos itself. He spent long nights refining his data. The faint glow of an oil lamp fell across parchment sheets filled with columns of numbers, hand-drawn lines, and precise angles. He would roll his metal spheres down polished wooden grooves again and again, recording how far they traveled and how long they took, until every variable had been tested. There were moments of frustration when his primitive instruments betrayed him, when the dripping of the water clock faltered, or when an imperceptible tilt in the ramp changed the results. But he persevered. He was not seeking perfection in tools, he was seeking perfection in understanding. Through these countless trials, he noticed something profound. As the ball rolled further, its speed increased steadily. This was acceleration, not a mystical property but a measurable one. Galileo had discovered that the velocity of a falling body does not remain constant, but increases by equal amounts in equal intervals of time. This simple yet revolutionary observation formed the foundation of a new physics. It was as if the veil had been lifted from nature's face, and beneath it lay a geometric harmony that no philosopher had imagined. He began to express his discoveries in mathematical form, introducing the concept of uniform acceleration. The distance a body traveled under constant acceleration, he found, was proportional to the square of the time it had been moving. To visualize it, he drew right triangles, where the height represented velocity, the base represented time, and the area represented distance. For the first time, motion was not a mystery of words, but a diagram of logic, a geometry of time. The implications were enormous. If motion could be described mathematically, then nature itself was written in the language of numbers. Galileo had turned motion into a form of poetry, one that used ratios instead of rhymes, curves instead of verses. It was an art of precision. The philosopher had become an architect of motion, laying the first stones of what would one day become the edifice of modern physics. In his lectures, he explained to his students that acceleration was the true essence of motion, not speed. Speed could change, but acceleration revealed the rule behind the change. He would demonstrate with simple experiments: a bronze ball rolling down a slope, another dropped freely from a height. To the eyes of the observers, it looked ordinary, even trivial, yet Galileo's commentary transformed it into revelation. He spoke of invisible forces of uniformity in nature, of the laws that govern all bodies equally. To hear him speak was to feel the pulse of the universe itself. His mind, restless and fertile, began to wander beyond the laboratory. If all bodies fell alike, he reasoned, then what would happen to a projectile launched into the air? What path would it trace as it rose and fell? He began to explore the motion of cannonballs, arrows, and stones hurled by hand. By combining horizontal motion with vertical fall, he discovered the elegant curve of the parabola. This insight would forever change the science of motion, transforming it from guesswork into calculation. The flight of an arrow, once governed by instinct, could now be predicted by mathematics. Every discovery drew Galileo closer to a grand unifying vision that all motion, from the simplest fall to the celestial dance of planets, followed the same natural principles. It was a daring thought, one that defied the old division between the earthly and the heavenly. For 2 millennia, philosophers had insisted that the heavens obeyed perfect, unchanging laws, while the earth was the realm of decay and imperfection. Galileo's experiments whispered otherwise. He saw no such separation in nature. The falling apple and the orbiting moon, he suspected, were partners in the same cosmic rhythm. As his ideas grew, so did his confidence. In his private notes, Galileo wrote that a moving object would continue in motion forever unless something opposed it, a concept now known as inertia. He arrived at it not by speculation, but by reasoning from experience. Watching a ball roll across a smooth surface, he noticed that it slowed not because it wished to stop, but because friction and resistance interfered. If those obstacles could be removed, the ball would roll endlessly. The insight was breathtaking. Rest was not the natural state of matter, as Aristotle had claimed. Motion was. Inertia became one of his greatest contributions, though it would later be perfected by Newton. Galileo had glimpsed a fundamental truth about the universe, that motion is not imposed upon matter by divine will but is its inherent property. This single idea would overturn the ancient worldview and place humanity on a path toward the mechanistic universe we understand today. Yet, despite his triumphs, Galileo faced skepticism. The universities of his time were bound by tradition. Professors clung to Aristotle's doctrines as if they were sacred scripture, and any attempt to contradict them was seen as arrogance or blasphemy. They dismissed Galileo's experiments as childish, his mathematics as irrelevant to philosophy. But Galileo refused to bow. He believed that knowledge must come from observation, not authority. Measure what can be measured, he said, and make measurable what cannot be measured. Those words became his creed. He continued to refine his timing instruments, developing pendulums and inclined tracks that allowed him to measure motion with increasing accuracy. The discovery of isochronism, the near constancy of a pendulum's swing, was another milestone. While watching a swinging lamp in the Cathedral of Pisa, he noticed that the period of oscillation remained almost the same, regardless of the amplitude of the swing. This observation would later lead to the invention of the pendulum clock, though Galileo himself would not live to see it completed. Even in casual observation, he found the fingerprint of mathematical order. The more he studied motion, the more he understood that the universe was governed by simplicity. There was no need for complex explanations or divine intervention. Nature followed rules that were elegant and universal. For Galileo, that was the greatest wonder of all, that truth could be both profound and simple, that the cosmos could be both infinite and intelligible. He felt a sense of awe that bordered on the spiritual. Mathematics, he once said, is the language in which God has written the universe. But Galileo's path was not without sacrifice. His relentless questioning drew the ire of powerful figures who feared that his discoveries threatened not only Aristotle, but theology itself. If motion and gravity could explain the behavior of the heavens, what room remained for miracles? What if Earth was not the center of creation? What if the laws he uncovered applied equally to the stars above? These were dangerous questions, and Galileo knew it. Yet he could not turn back. For him, to deny what he had seen with his own eyes was a betrayal of truth itself. As his studies advanced, he built increasingly complex experiments to test his theories. One of his favorites involved sliding balls down long, polished ramps and measuring how far they traveled after rolling off the end. He discovered that the balls did not fall vertically but traced smooth parabolic arcs, confirmation that gravity acted uniformly and continuously, not in sudden impulses. Each result reinforced his conviction that motion followed mathematical law. In his later writings, especially in discourses and mathematical demonstrations relating to two new sciences, Galileo gathered the fruits of decades of thought. There, he presented his findings on motion and strength of materials in the form of dialogues, accessible yet profound. It was the culmination of his life's work, a testament to the power of reason. He showed how the same principles governed both the fall of a stone and the bending of a beam, uniting mechanics and geometry under one framework. The work was more than a scientific treatise. It was a declaration of intellectual freedom. Even under house arrest in his later years, when blindness had stolen his sight, Galileo's mind continued to soar. Deprived of instruments, he relied on memory and imagination, replaying experiments in his thoughts, tracing invisible lines of motion across the darkness. His last words about science were not of despair but of defiance. "I do not feel obliged," he said, "to believe that the same God who has endowed us with sense, reason, and intellect has intended us to forego their use." He had lost his freedom, but not his vision. His influence spread like light through the corridors of time. The generations that followed, Descartes, Newton, Leibniz, would build upon his foundations. Newton himself once wrote that if he had seen further, it was by standing on the shoulders of giants. One of those giants was Galileo Galilei, the man who turned falling bodies into the language of the cosmos. The concepts of acceleration, inertia, and parabolic motion, all essential to Newton's laws, were born from Galileo's humble experiments with ramps and spheres. Galileo's legacy was not merely in the laws he discovered, but in the method he championed. He taught humanity to doubt wisely, to test fearlessly, to measure carefully. He turned curiosity into discipline, observation into principle. The spirit of his work lived on in every scientist who refused to accept tradition without evidence. His ramps became the laboratories of the modern world, his spheres the satellites of our age. Today, centuries later, the echo of his rolling spheres still resounds in every equation of motion, in every rocket launch, in every fall observed through the lens of physics. When astronauts orbit the Earth, they follow trajectories first traced by Galileo's imagination. When a physicist writes the equation S tanto gt dive, they are continuing a conversation he began in a small room in Padua, counting drops of water by candlelight. His life reminds us that great revolutions often begin quietly, with a simple question, a modest experiment, a stubborn refusal to accept what everyone else believes. Galileo did not have armies or wealth. He had curiosity, he had courage, and above all, he had faith in reason. Through his experiments on motion, he proved that truth needs no permission to exist. It only needs a mind brave enough to seek it. In the story of motion, Galileo was both author and explorer. He mapped a new world, one not of continents but of principles, where every fall, every swing, every rotation could be explained. The universe, once a mystery of divine perfection, became a realm of discoverable law. And in that transformation, humanity itself moved, from darkness to light, from belief to understanding, from the silence of obedience to the music of reason. As the centuries passed, his discoveries became the invisible scaffolding of civilization. Bridges, clocks, engines, and satellites all owe something to the man who dropped 2 spheres and defied 2,000 years of dogma. Yet perhaps Galileo's greatest achievement was not scientific but human. He taught us that the act of questioning is sacred, that to seek truth, even against the tide of authority, is the noblest of pursuits. In the end, Galileo's story is the story of motion itself, not just the motion of bodies through space, but of the human mind through ignorance toward enlightenment. His experiments marked the moment when knowledge began to move with purpose, when thought itself gained momentum. The world has never stood still since. In the early years of the 17th century, a quiet revolution was brewing in the world of science. Across Europe, inventors and philosophers sought new ways to peer deeper into nature's mysteries. It was an age of discovery, of daring voyages across oceans and bold voyages of the mind. And in the small city of Padua, an Italian scholar named Galileo Galilei stood on the threshold of a revelation that would forever alter how humankind saw the heavens. The year was 6. News had begun to travel through the corridors of Europe about a curious device first constructed in the Netherlands. A tube fitted with lenses that could make distant objects appear closer. It was a simple instrument, a toy almost, sold by spectacle makers in the marketplaces of Holland. Merchants used it to spot ships at sea before they reached the harbor. But when the rumor reached Galileo, it sparked a flame of imagination that refused to fade. He saw in that crude device not a novelty, but a doorway, a way to extend the human eye beyond the limits of earthly sight. Galileo, ever restless, could not ignore the idea. Without ever having seen one of these instruments, he began to imagine how it might work. He knew the principles of refraction, how light bends as it passes through glass, and how lenses could converge or diverge beams of light. For days, he studied the mathematics of curvature and distance, experimenting with scraps of glass, grinding and polishing them with his own hands. He refused to copy, he sought to improve. In his mind, the telescope would become more than a tool, it would become an instrument of truth. After long nights of labor, his first telescope came to life. It was rough, imperfect, yet wondrous. He carried it up the tower of Padua University, pointed it toward the horizon, and held his breath. The rooftops of distant houses leapt forward, the spires and trees, once faint, now stood in startling detail. The world had grown closer. With childlike excitement, he refined his creation, adjusting the lenses, calculating focal lengths, learning from every imperfection. Each experiment led to a clearer image, a sharper focus, a greater reach. Before long, Galileo's telescope could magnify objects 8 times, then 20, then 30. What had been a merchant's curiosity had become a scientist's miracle. The people of Padua were astonished. When he demonstrated it to local officials, they gasped as they saw distant ships that were invisible to the naked eye, their sails crisp and clear. The Venetian Senate invited Galileo to Venice, where he presented the instrument to the Doge himself. Standing on the high tower of St. Mark's Basilica, the Doge gazed at ships many miles away and was struck with awe. For this marvel, the Senate rewarded Galileo with a lifetime appointment at the University of Padua and a significant pay raise. Yet for Galileo, the greatest reward was not wealth or fame. It was the vision of what lay ahead. He had not yet turned the telescope toward the heavens, but deep within he knew that when he did, the sky would never look the same again. On a clear night in the autumn of 1609, Galileo carried his telescope to the open fields outside Padua. The moon hung bright in the sky, silver and serene. Every astronomer before him had described it as a perfect sphere, smooth and flawless, the symbol of divine harmony. But when Galileo lifted the telescope to his eye, what he saw shattered centuries of belief. The moon was not perfect at all. It was rugged, scarred, and mountainous. Its surface was carved with shadows and ridges, with peaks that caught the sunlight and craters that sank into darkness. It was a world, not a divine lamp. He watched in silence, heart racing, as the truth unfolded before him. The moon, long considered a celestial mirror of perfection, bore the marks of nature's same rough hand that shaped the earth. It was solid, tangible, alive. The heavens, it seemed, were not made of ethereal perfection, but of the same matter as our own world. He began to sketch what he saw, painstakingly, faithfully, drawing the moon's changing face night after night. His notebook filled with maps of craters, mountains, and seas of shadow. For the first time in human history, the moon had been seen for what it truly was. Galileo's telescope had broken the wall between heaven and earth. Word spread quickly through Padua, then Venice, then all of Italy. Scholars, priests, and nobles came to see this miraculous instrument and the wonders it revealed. But Galileo's curiosity did not rest with the moon. He turned his telescope toward the stars themselves. When he pointed it at the Milky Way, what had once seemed a misty river of light transformed before his eyes into a vast multitude of stars, countless, unnumbered, each a sun in its own right. The heavens, once thought few and ordered, exploded into infinity. He wrote of it with awe. The galaxy is nothing else but a mass of innumerable stars planted together in clusters. The universe had suddenly grown immeasurable. One night, he turned his telescope toward Jupiter, and what he saw would ignite one of the greatest revolutions in science. Near the planet's bright disk he noticed 3 tiny points of light like faint stars. The next night they had shifted position. On the third, there were 4. Night after night he watched as these small orbs moved back and forth around Jupiter, never straying far, as though bound to it by an invisible leash. The realization struck him with electric force. These were moons, circling Jupiter just as our moon circles Earth. For 2,000 years, philosophers had declared that all heavenly bodies revolved around Earth. Now, in his small telescope, Galileo saw undeniable proof that this was not so. The heavens had other centers, other systems. The Earth was not the sole pivot of the cosmos. His heart pounded with excitement. He named the 4 moons the Medici stars, in honor of the powerful Medici family of Florence, hoping to gain their patronage. But beyond politics, he knew what this discovery meant. It was a dagger aimed at the heart of the geocentric universe. The telescope had become a weapon of truth. Night after night, Galileo continued his celestial journey. He observed the phases of Venus, which waxed and waned like the moon, proof that Venus orbited the Sun, not the Earth. He saw the strange ears of Saturn, though his telescope was not yet powerful enough to resolve its rings. He watched the dark spots move across the face of the Sun, daring to observe through filtered glass, and he realized that even the Sun, symbol of divine purity, was not perfect. It rotated, and its surface changed. The heavens were not unalterable, they were dynamic, alive, and imperfectly beautiful. Every discovery was another step away from the old world of Aristotle and Ptolemy and closer to the new vision of Copernicus. Galileo's telescope had become the eye of a new age. Through it, humanity saw not only the universe, but itself, small, fragile, yet capable of wonder beyond measure. But these revelations also stirred fear and hostility. The perfection of the heavens had been a cornerstone of religious belief. To suggest otherwise was dangerous. When Galileo published Sidereus Nuncius, the Starry Messenger, in 1610, his words sent shockwaves through Europe. The book was short but explosive, filled with sketches and observations that defied centuries of theology. Scholars admired it, priests condemned it. Some accused him of illusion, of witchcraft, of tricking the eye with lenses. Others hailed him as the herald of a new dawn. In Florence, under the patronage of the Medicis, Galileo became a figure of fame and controversy. He was invited to courts, honored by princes, debated by philosophers. Yet beneath the admiration lay the simmering unease of the Church. For if the earth was not the center of creation, then what of Scripture? What of the divine order that placed humanity at the heart of all things? Galileo's telescope had not only extended vision, it had extended doubt. Still, Galileo pressed forward. He designed stronger telescopes, refining his lenses, grinding glass with unmatched precision. He taught himself the art of optics, understanding how spherical aberration distorted images and how to minimize it through careful curvature. His instruments became prized possessions, sought after by kings and scholars alike. None could match the clarity of Galileo's craftsmanship. His telescopes were more than devices, they were symbols of a new way of knowing, a knowledge that came not from authority, but from seeing. Every time he looked through one, he felt a sacred connection with the universe, as though the divine had written its truth not in books, but in the stars themselves. He once said, "I give infinite thanks to God, who has been pleased to make me the first observer of marvelous things." To Galileo, his discoveries did not weaken faith, they deepened it. He believed that to observe the works of creation was to honor the Creator. But not all agreed. By 1611, when he visited Rome to present his findings, he was both celebrated and scrutinized. The Jesuit astronomers of the Collegio Romano confirmed his observations, yet many theologians warned that his interpretation strayed dangerously close to heresy. Galileo, ever bold, replied that Scripture teaches us how to go to heaven, not how the heavens go. It was a statement of quiet rebellion, reason asserting itself against dogma. And so, with every glance through the telescope, Galileo was not only observing the cosmos, he was redefining humanity's place within it. He had turned a humble spyglass into an instrument that bridged earth and heaven, revealing a universe of depth, movement, and imperfection, a universe where truth could no longer be confined by tradition. The telescope became his voice, his defiance, his legacy. What began as a rumor from the Netherlands had become a revolution in Italy. Through Galileo's genius, a simple tube of glass and metal became the key to the infinite, and with it, mankind's gaze would never again be bound to the horizon. The more Galileo gazed through his telescope, the more the universe began to speak, not in words but in light. Each night became a conversation between one man and the cosmos. The instrument he had built with his own hands now opened doors no priest, no philosopher, no emperor had ever walked through. It was a fragile thing, wood, glass, brass, but through it streamed a vision vast enough to humble eternity. As the months turned into years, Galileo's discoveries multiplied. His journal became a treasure chest of sketches and calculations, each one a testament to human curiosity. He drew Jupiter's moons in careful sequence, plotting their positions as they orbited with clock-like precision. He mapped the changing shadows on the moon's craters, noting how the sunlight revealed their rugged forms at different angles. He charted the phases of Venus with meticulous detail, and from these simple observations he confirmed what Copernicus had only dared to propose, that the planets revolve around the sun. It was a triumph of sight over superstition, of observation over tradition, but triumph has its price, and Galileo's price was isolation. Many of his contemporaries refused to look through the telescope. Some feared that what they would see might shake their faith. Others doubted the very existence of what he described, believing that the lens itself played tricks on the eye. They said the moons of Jupiter were illusions, the mountains of the moon imperfections in the glass, the spots on the sun optical flaws. Galileo, frustrated yet patient, invited them all to witness with their own eyes. Few accepted. He realized then that blindness is not only of the eyes but of the mind. He had given the world a new way to see, but not everyone wished to see anew. Still, he continued. Night after night, he adjusted his telescope, polishing its lenses, refining its focus. Each improvement brought him closer to the essence of clarity. Clarity not only of vision but of truth. The telescope became his companion, his confidant. When he looked through it, he felt both small and infinite. The stars were no longer distant ornaments hung upon a perfect sphere. They were suns scattered across immeasurable space. He began to imagine that each one might have its own worlds, its own moons, perhaps even its own forms of life. It was a thought both exhilarating and terrifying, for it suggested that humanity was not the center of creation, but a part of something boundless. This new vision of the cosmos unsettled the Church. The Scriptures had long been interpreted to place Earth and mankind at the center of divine order. Galileo's telescope threatened that order. His observations did not fit the perfect geometry of Ptolemy, they fit the daring simplicity of Copernicus. He did not preach rebellion, yet his discoveries whispered it. They whispered that the universe was governed not by miracles, but by laws that could be known and measured. In 1610, his book The Starry Messenger had made him famous. Now, fame turned to scrutiny. Theologians debated his findings. Some tried to reconcile them with doctrine, others sought to condemn them. Galileo wrote letters, essays, and treatises defending his position. He argued not as a heretic, but as a believer in reason. a man who saw science as a way to glorify creation by understanding it. Yet the more he explained, the deeper the chasm grew between the world of faith and the world of observation. He traveled to Rome again, hoping to find allies among the scholars of the Church. At first, he was welcomed with curiosity. The Jesuit astronomers confirmed his discoveries, even Pope Paul V granted him an audience. But approval was fragile. The whispers of heresy grew louder in corridors he could not walk. Theologians warned that Galileo's interpretations of the heavens contradicted Scripture. The notion that Earth moved around the sun was declared philosophically absurd and theologically dangerous. Galileo tried to bridge the gap. He insisted that Scripture and science spoke different languages, that one taught moral truth and the other natural truth. But his reasoning, no matter how eloquent, fell on ears closed by fear. The telescope that had revealed the beauty of creation now stood accused of revealing too much. Still, he would not recant his sight. He built new telescopes, each more powerful than the last. Some he gave to princes, others to fellow scientists. They became objects of wonder across Europe, instruments of navigation and war as well as study. With them, explorers mapped the seas, generals surveyed the battlefield, and astronomers from England to Bohemia confirmed his celestial findings. The telescope had escaped the confines of Galileo's workshop and entered the bloodstream of civilization. But while the instrument prospered, its maker grew wary. The endless disputes, the letters of accusation, the envy of lesser minds, all took their toll. He longed for peace, for quiet nights alone with the stars. Yet he knew that knowledge once seen could not be unseen. The world had changed because of his vision, and there was no turning back. In 1616, the Church formally condemned the heliocentric model. Galileo was warned not to teach or defend it. He obeyed in public but continued to ponder it in private, studying, writing, waiting for the right moment. When a new pope, Urban V, ascended to power, a man who once admired Galileo's intellect, he saw hope for reconciliation. That hope would soon be shattered. By 1632, Galileo published Dialogue Concerning the Two Chief World Systems, a brilliant work presented as a conversation between three characters debating the geocentric and heliocentric views. Though written with wit and elegance, the dialogue left little doubt about where Galileo's sympathies lay. His reasoning was clear, his evidence undeniable. But the Church, now under growing pressure from conservative forces, saw in his book not inquiry, but defiance. The man who had given humanity the telescope was summoned before the Inquisition. The trial was a theater of fear. In a chamber lit by candles, beneath frescoed ceilings and the gaze of cardinals, Galileo stood accused of heresy. They read aloud his statements, his writings, his letters. They demanded that he deny what his eyes had seen. At 70, frail and weary, Galileo faced the impossible choice between truth and survival. He chose life, but not surrender. He was forced to recant, to declare that Earth did not move. As he knelt before the tribunal, legend says he whispered, "E per se move," and yet it moves. Those words, whether spoken or imagined, became the anthem of reason defying authority. The man who had seen the mountains of the moon and the moons of Jupiter was now confined to his home in Arcetri, under permanent house arrest. But even in captivity, his mind roamed free. Blindness crept upon him, a cruel irony for the man who had given sight to the world. Yet even in darkness, he continued to think, to dictate, to explore through imagination the worlds he could no longer see. In those final years, the telescope remained by his side, its lenses worn, its brass dulled by time. He would hold it, tracing its contours with his hands, remembering the nights of discovery, when he first saw the universe come alive. His students visited him, among them Vincenzo Viviani, who later wrote that though Galileo had lost his sight, he had never lost his vision. He dictated his last great work, Two New Sciences, in which he summarized his discoveries on motion and materials, the very foundations of physics. It was a final message to the world, a passing of the torch to future generations. The telescope had shown him the heavens. Now his mind turned back to Earth, to the mechanics of the world beneath his feet. Galileo died in 1642, the same year Isaac Newton was born, as if nature itself had decided that the flame of discovery should never go out. The telescope, his gift to humanity, would soon be pointed by others toward the depths of space. Newton would use Galileo's laws of motion to explain the orbits that Galileo had glimpsed. Kepler would use his own observations to describe the harmony of the spheres. Each stood on the foundation laid by the man from Pisa who refused to stop looking. In the centuries that followed, the telescope evolved beyond Galileo's dreams. Reflecting mirrors replaced lenses, observatories rose upon mountaintops, and eventually, space-borne instruments drifted beyond the atmosphere to peer into the birthplaces of stars and galaxies. Yet every telescope, from the smallest backyard lens to the mighty Hubble, carries within it a spark of Galileo's spirit. Every image of a distant world, every discovery of a new star, traces its lineage to that night in 1609, when one man first turned a handmade tube of glass toward the moon. Galileo's story is not merely about invention, it is about courage, the courage to trust one's senses, to defy consensus, to see what others refuse to see. The telescope was more than a scientific tool, it was a symbol of liberation. Through it, humanity escaped the prison of the geocentric mind and began its long journey into the cosmic unknown. Even today, when astronomers photograph galaxies millions of light-years away, they echo Galileo's first act of faith, the belief that truth reveals itself to those who dare to look. His insistence on evidence over dogma became the cornerstone of the scientific method. His struggle against blindness, both physical and societal, remains the struggle of every thinker who seeks clarity in a world clouded by fear. In the end, Galileo's telescope changed not only what we see but how we think. It taught us that the universe does not revolve around us, and that humility before the cosmos is the beginning of wisdom. It showed that discovery begins not with certainty but with curiosity. And it proved that a single lens, in the hands of a determined mind, can transform the darkness of ignorance into the light of understanding. If one were to stand beside Galileo now, looking through that first crude instrument, the view might seem faint, blurred compared to the powerful telescopes of our age. Yet what matters is not the clarity of the glass, but the clarity of the mind behind it. For through that simple device, Galileo saw what others could not. That knowledge is not bestowed, it is earned. The telescope was his rebellion, his prayer, and his triumph. It was the bridge between faith and reason, between heaven and earth, between what was believed and what could be known. When he lifted it to the sky, he lifted all of humanity with it. And though centuries have passed, each time we look through a telescope, we are, in some silent way, standing beside him under the Italian night, listening to the stars whisper the same truth he heard, that the universe is vast, that it moves, and that it awaits the eyes of those brave enough to see. Under the dark velvet sky of the early 17th century, Galileo Galilei lifted his telescope once more toward the heavens. What he saw would shatter centuries of belief and redraw the map of the cosmos. Through that slender tube of glass, the universe revealed its secrets not as divine perfection, but as a vast and restless system of motion and change. Galileo's discoveries were not mere observations, they were revelations. The telescope had given him the eyes of the future, and what those eyes beheld transformed humanity's place in the grand design of existence. The first revelation came with the moon. For generations, philosophers had declared it a perfect, polished sphere, unblemished by imperfection, an image of celestial purity. But as Galileo focused his telescope upon it, shadows danced across rugged terrain, deep valleys, and towering mountains. The moon was a world like Earth, scarred, uneven, and alive with light and darkness. This was the first crack in the crystal spheres of ancient belief. The heavens were not immutable. They were made of the same rough matter as our own world. Then came the discovery of Jupiter's moons. On a cold January night in 1610, Galileo noticed tiny points of light beside the great planet. Night after night, he observed them shifting positions, sometimes appearing, sometimes vanishing behind the planet's glow. At first, he thought they were stars, but their motion betrayed their nature. They were satellites orbiting Jupiter. It was an idea both astonishing and heretical. Not everything revolved around the Earth. In those small moving dots, Galileo found proof that Copernicus was right. The cosmos was a system of many centers, not one. He named them the Medicean stars, after his patrons, the powerful Medici family. But to history they became known as the Galilean moons, Europa, Ganymede, and Callisto. Their discovery marked a turning point in human understanding. For the first time, mankind saw with certainty that celestial bodies could revolve around one another, independent of Earth's dominion. It was as if the universe itself whispered to Galileo, the old order is broken. Not long after, he turned his lens toward Venus. As the bright planet moved through the sky, Galileo noticed that it displayed phases, crescent, half, and full, just like the moon. This could only be explained if Venus orbited the Sun, not the Earth. With that realization, the last doubt about the heliocentric model began to crumble. The Sun, not Earth, was the true center of motion for the planets. Galileo's gaze then met the blinding brilliance of the Sun itself. Through tinted lenses, he saw dark, shifting blemishes, sunspots, moving slowly across its face. The heavens, thought to be eternal and flawless, were in fact dynamic, changing, and imperfect. These spots, he concluded, were not small clouds or shadows of planets, but marks upon the Sun's surface itself, proof that even the great star at the heart of the solar system was a living, evolving body. Each discovery struck like thunder across Europe. The church, the universities, and the philosophers of tradition trembled. The universe they had built upon divine perfection was now crumbling under the steady gaze of Galileo's telescope. He was accused of arrogance, of meddling with the sacred order of heaven, yet all he had done was look with a clearer eye and a freer mind. To the common people, his discoveries were a wonder. They crowded around his telescopes, marveling at the idea that the moon had mountains, that Jupiter had moons, that the stars were numberless beyond measure. The universe, once closed and ordered, had opened into infinite mystery. For the first time, humanity felt both smaller and greater at once. Smaller because Earth was not the center of all things, greater because the human mind could comprehend the vastness beyond it. Galileo's writings spread quickly, carried by scholars and sailors alike. His starry messenger became a declaration of a new age, an age where evidence triumphed over assumption, where sight replaced faith in authority. He had revealed a universe of movement, imperfection, and law, a cosmos alive, not static. The celestial spheres of Aristotle had shattered, and in their place stood a vision of infinite space ruled by natural principles. Though his discoveries would earn him both fame and condemnation, Galileo knew that he had glimpsed something eternal. The telescope had shown him that truth was not confined to scripture or tradition, but written in the language of light and motion. The stars were not silent, they spoke through mathematics, through observation, through wonder, and Galileo, the man who dared to listen, became the voice of a new world awakening to the power of reason. In those nights of discovery, as he stood beneath the Italian sky, the air crisp and silent, Galileo must have felt the weight of his vision. Each glimmering point of light was a promise of unending exploration, of questions yet to be asked. The universe was no longer a closed book, but an infinite story waiting to be read. Through the eye of his telescope, humanity took its first step into that story, and the cosmos, once distant and divine, became the vast home of human curiosity forever. As the light of discovery spread across Europe, Galileo Galilei found himself at the crossroads of knowledge and power. His observations had torn through centuries of inherited belief, and the world was beginning to shift beneath the weight of his revelations. Yet, for all his brilliance, Galileo was not a man living in an age of freedom. He lived under the watchful gaze of a church that saw the heavens as its divine domain. Every movement of a planet, every turning of a star, had long been interpreted through Scripture, and now one man's telescope threatened to overturn that sacred order. At first, Galileo hoped his discoveries would strengthen faith, not challenge it. He believed that understanding the universe was an act of reverence, that uncovering the laws of nature was a way to admire the work of the Creator. But the more he spoke, the more the walls of orthodoxy closed in. His insistence that Earth moved around the sun clashed directly with the teachings of Aristotle and the words of the Bible as interpreted by the Church. What he saw as truth, others saw as defiance. In 1616, the storm broke. The Catholic Church, already wary of the growing influence of the Reformation, viewed any challenge to its authority as dangerous. The Copernican theory, the idea that Earth orbited the sun, was officially declared heretical. Books supporting it were banned. Galileo was warned not to hold, teach, or defend such ideas. Outwardly, he obeyed. Inwardly, he burned with conviction. He knew what he had seen through his telescope, and he could not unsee it. For years, he stayed silent, biding his time, refining his work, and studying the subtle patterns of motion and gravity. He waited for a change in the wind, and it came in 1623, when a new pope ascended to the throne of St. Peter Urban V. This pope was a scholar, a man of intellect who admired Galileo's genius, encouraged Galileo return to his pen, believing that perhaps reason and faith could coexist. It was in this spirit that he wrote his most daring and beautiful work, Dialogue Concerning the Two Chief World Systems. Written as a conversation between three characters, it explored both the geocentric and heliocentric models. The dialogue was meant to appear neutral, a simple exploration of ideas, but Galileo's wit was sharp and his sympathies were clear. His arguments for the sun-centered universe were too persuasive, his defense of the old Earth-centered view too feeble. The book became a sensation, spreading across Europe like wildfire. But its brilliance also sealed his fate. Those in the Church, who had always viewed him with suspicion, saw in the dialogue a direct challenge to their authority. They claimed Galileo had mocked the Pope himself through one of his characters. The admiration of the past turned swiftly into hostility. In 1633, the Inquisition summoned Galileo to Rome. Old, ill, and nearly blind, he obeyed the summons, knowing what awaited him. The trial of Galileo was not simply a trial of a man, it was a trial of an idea. In a hall filled with candles and shadows, beneath the stern faces of cardinals and inquisitors, he stood accused of heresy. They read his words aloud, twisting them into threats against the faith. He was shown the instruments of torture, a silent reminder of the price of defiance, and though his heart remained unbroken, his body could not bear the weight of persecution. At last, under pressure and fear for his life, Galileo recanted. He denied the motion of the earth, renounced the very truths he had discovered with his own eyes. The tribunal declared him guilty, his books were banned, and he was sentenced to house arrest for the rest of his life. Yet as he rose from his knees, legend says he whispered a defiant phrase, "E per si move," and yet it moves. Whether he truly spoke those words or not, they echoed across history as the quiet cry of reason against tyranny. Exiled to his villa in Arcetri, near Florence, Galileo spent his remaining years in isolation. But solitude could not silence him. Though blindness eventually claimed his sight, his inner vision only sharpened. He dictated his final masterpiece, Two New Sciences, a work that would lay the foundation for modern physics. In its pages, he explored motion, inertia, and acceleration, the principles that would later inspire Isaac Newton. Even under the shadow of condemnation, Galileo's mind reached for the future. His persecution became one of the most powerful symbols in human history, the struggle between knowledge and authority, evidence and dogma, light and darkness. Yet Galileo was never a rebel for rebellion's sake. He did not hate the Church, he loved truth more. He believed that faith and reason could walk hand in hand, that to study the universe was to understand the mind of God, but his age was not ready for such a union. When Galileo died in 1642, he left behind more than instruments and manuscripts. He left behind a legacy of courage, the courage to ask, to doubt, to look, and to see. His condemnation would one day be reversed, his name restored, but his example never faded. The same church that silenced him would, centuries later, honor him as one of the greatest thinkers who ever lived. Galileo's struggle was not in vain. His defiance ignited a spark that lit the path for all who came after him: the scientists, the thinkers, the dreamers who refused to accept what they were told without proof. His trial became a turning point in the history of thought, the moment when humanity began to understand that truth is not defined by power but by evidence. And so, even as the world outside his window remained still, the universe he had revealed continued to move. The planets followed their paths, the stars burned in their silent glory, and Galileo's name became a beacon for every mind that dares to challenge the darkness. His telescope had once shown him the infinite expanse of the heavens. His courage showed the world the infinite strength of the human spirit. When the echoes of Galileo's trial faded into silence, his name did not vanish with the decree of the Church. Though confined to his home, his ideas began to drift far beyond the walls that imprisoned him. Like the light that still travels from distant stars, his discoveries journeyed across generations, unbound by time or fear. The sixth chapter of his legacy was not written in his lifetime, but in the lives of those he inspired, the thinkers, mathematicians, and scientists who carried his torch into the dawn of modern science. Galileo had laid the foundation. His study of motion, his insistence on observation and experiment, became the cornerstone upon which the scientific method was built. In the years after his death, others began to build upon his truths. In England, a young boy named Isaac Newton would grow up reading Galileo's works, marveling at his studies of acceleration and falling bodies. Newton would later say, "If I have seen further, it is by standing on the shoulders of giants." And among those giants, Galileo stood tallest. The laws that Galileo uncovered, though simple in form, carried immense power. His experiments with inclined planes revealed that motion followed predictable patterns, that acceleration was constant, and that objects fell not because of their weight, but because of gravity's unyielding pull. These principles, refined by Newton, would soon govern not just the motion of falling apples, but the motion of planets, stars, and galaxies. Galileo's mind had reached from the hills of Italy to the very edges of space. Yet his influence was not only scientific, it was philosophical. He had changed the way humanity thought about truth. For centuries, knowledge had been accepted because it was spoken by authority. By Aristotle, by theologians, by tradition. Galileo shattered that chain. He taught the world that truth is not proclaimed, it is discovered, that a single observation, if true, can outweigh the wisdom of centuries. His defiance of dogma became the seed of a revolution that would blossom into the Enlightenment. In the centuries that followed, Europe's intellectual landscape transformed. Telescopes multiplied and grew in power. Observatories rose on mountain peaks. Astronomers like Huygens, Cassini, and later William Herschel peered deeper into the heavens, finding new moons, new planets, and new laws of motion. Each of them carried within their instruments the spirit of Galileo. Every time a telescope turned skyward, it repeated his act of faith, that nature could be understood through reason. Even the Church, which once condemned him, began to soften over time. His books were quietly removed from the index of forbidden works. Scholars began to study his writings with admiration rather than suspicion. And centuries later, Pope John Paul II would formally acknowledge the injustice done to him, calling Galileo a man of faith whose genius had illuminated the path of science. The same institution that once silenced him now recognized that his discoveries had revealed the grandeur of creation in a way no philosopher ever could. Galileo's influence reached beyond the laboratory and into the soul of civilization. His insistence on evidence reshaped art, politics, and philosophy. Painters began to see light not as a divine symbol, but as a phenomenon to be studied. Engineers built machines inspired by his mechanical insights. Navigators crossed oceans using instruments derived from his designs. The spirit of inquiry he ignited became the heartbeat of progress. In the modern world, his name is carved not only in history, but in the stars themselves. Craters on the moon bear his name, satellites around Jupiter, his beloved planet, are called the Galilean moons, and spacecraft like the Galileo probe continue his quest among the heavens. His once simple telescope has evolved into immense observatories orbiting far above Earth, peering into galaxies billions of light-years away. Each photograph of a distant world, each measurement of cosmic light, is a tribute to the man who first dared to look up and question. But perhaps Galileo's greatest legacy lies in his unshakable belief that nature speaks a universal language. Philosophy, he once wrote, is written in that great book of the universe, which stands continually open to our gaze, but it cannot be understood unless one first learns to comprehend the language and read the characters in which it is written. It is written in the language of mathematics. These words became the creed of modern science. From the motion of atoms to the dance of galaxies, every discovery since has echoed his insight that the cosmos is governed by laws that reason can unveil. Even in his final years, blind but unbroken, Galileo sensed that the future would vindicate him. He once said to his pupil, "The truth cannot be hidden forever." And he was right. Today, when students learn about inertia, acceleration, or the orbit of planets, they are walking in his footsteps. When telescopes scan the skies for exoplanets or the faint afterglow of the Big Bang, they are continuing his mission to understand the universe not by faith alone, but by evidence, by sight, by reason. Galileo's story reminds us that every great leap in knowledge comes with a struggle. He faced ridicule, isolation, and judgment, yet never surrendered his curiosity. His courage redefined what it means to be human, to question, to observe, to seek truth even when it is dangerous. The cosmos he revealed is vast and different, and awe-inspiring, but in discovering its laws, he also revealed something divine within humanity itself, the power of understanding. In the stillness of the night sky, long after his passing, the stars continue to shine as they did when Galileo first turned his telescope upon them. But humanity no longer looks at them with fear or ignorance. We look with wonder, with gratitude, and with a sense of belonging. The heavens that once condemned him have become his eternal monument. Every glimmering star carries the light of his rebellion, every telescope the echo of his vision. Galileo Galilei, the rebel who redefined motion in the cosmos, did more than change our view of the universe. He changed the way we see ourselves within it. The story of Galileo Galilei does not end with his death. It begins anew in the echoes of his legacy. His life, filled with discovery, struggle, and defiance, became a mirror reflecting humanity's eternal quest for truth. The seventh and final chapter of his journey is not about the man alone, but about what he awakened in the human spirit. The courage to question, the hunger to know, and the unyielding belief that reason can illuminate even the darkest corners of ignorance. Centuries have passed since Galileo raised his telescope toward the stars, yet his influence still breathes in every scientific mind, every instrument that scans the heavens, and every question that challenges the limits of belief. His life was a battle between light and shadow, between faith and evidence, and though he was condemned in his time, the light of his truth endured. His discoveries did not simply expand our knowledge of the cosmos, they redefined humanity's place within it. Before Galileo, the universe was a stage where the earth stood immovable, the center of creation. After him, we found ourselves adrift in a vast, dynamic sea of motion, a universe alive, infinite, and governed by laws of nature that no power could silence. His courage transformed not only science but the human condition itself. He showed that one person, guided by curiosity and reason, could stand against centuries of tradition. In doing so, Galileo became the symbol of intellectual freedom, a voice for every thinker who would ever face the weight of authority. His defiance before the Inquisition was not the rebellion of arrogance but of conviction. The unshakable belief that seeing with one's own eyes is greater than accepting without question. That belief became the seed of modern thought, giving rise to generations of innovators who followed his path: Newton, Kepler, Faraday, Einstein, and countless others. Each of them carried forward the same torch of curiosity that Galileo lit under the Tuscan sky. His methods became the backbone of the scientific revolution: observation, experimentation, and mathematical reasoning, the pillars of modern science, were the instruments he gave to humanity. Before Galileo, philosophy sought truth through logic alone. After him, truth demanded proof through evidence. He turned the study of the universe from speculation into science. It was a transformation so profound that it reshaped the destiny of civilization. The modern world, from the smallest machine to the largest observatory, is built upon the foundation he laid. Yet Galileo's legacy extends beyond laboratories and telescopes. His struggle was deeply human, echoing in every heart that has ever fought for the right to think freely. He lived and died believing that truth, once seen, cannot be unseen, and in that belief he taught the world the cost of enlightenment. Progress, he showed, is never given freely. It must be earned through courage and sacrifice. His voice, silenced by decree, continues to speak across time, reminding us that ideas cannot be imprisoned, and that the universe favors those who seek to understand it. Even today, as we send telescopes into orbit and spacecraft beyond the solar system, we are still following the path he carved. The Galileo spacecraft that explored Jupiter in the 1990s carried not just instruments, but the spirit of the man who first saw its moons through a handmade lens. Every discovery made beyond Earth's horizon, every star, planet, and galaxy revealed, echoes the same question that burned within him: what lies beyond what we see? The cosmos, once a realm of mystery and fear, became through Galileo's eyes a place of wonder and law. He replaced superstition with symmetry, divine command with natural principle. His universe was not one ruled by caprice but by consistency. A vast, beautiful system guided by reason. That idea gave humanity something greater than knowledge. It gave us purpose. To understand, to explore, to keep asking, to never stop looking up. And so, Galileo's true triumph was not in his inventions or even his discoveries, but in his transformation of the human mind. He taught us that to look through the telescope is to look beyond boundaries, the boundaries of dogma, of ignorance, of fear. He proved that the smallest lens could open the largest questions, that a single observation could move the world. His rebellion was not against faith but against blindness. His loyalty was not to authority but to truth. In the end, Galileo's name became eternal not because he conquered the heavens, but because he liberated the human spirit. His life reminds us that progress is born not from comfort, but from challenge. From those moments when one voice dares to speak against the silence of conformity. He was a man punished for seeing too much, yet blessed for showing others how to see. As night falls and the stars emerge one by one, their light carries the memory of his gaze. The same constellations that once watched him through the narrow streets of Florence now shine upon a world transformed by his vision. Every beam of starlight that passes through a telescope, every calculation that measures the speed of a planet, every whisper of wonder from a child looking at the sky, all of it belongs to Galileo. He redefined not only motion and the cosmos but the very act of knowing itself. In the quiet of history, his story endures. A man who looked at the heavens and saw truth where others saw heresy, who faced the wrath of power yet never surrendered to it, and who taught the world that the universe is vast, knowable, and beautiful. The rebel who redefined motion and the cosmos left behind more than science. He left humanity with eyes forever open to the infinite.